A fixed mass ideal gas expands its volumes from V1 to V2 through the following three thermodynamic processes: isobaric, isothermal, and adiabatic. The gas starts from the same initial state A and attains states B, C, and D respectively. See the figure below. A. Which curve represents an adiabatic process? B. Rank from largest to smallest the heat absorbed in the three processes. Part A. Which curve represents an adiabatic process? In this diagram, PV diagram, P is pressure in Pascal and the V is the volumes of the gas in meter cubes. There are three processes given in this diagram: AB, AC, and the AD, where the A, B, C, D are four different states. B, C, D have the same initial states for which is A. So initial state, the volume is V1, and final state for B, C, D through three different processes, the final volume is V2. Now, obviously, from A to B, the process is isobaric because the pressure is constant. So between AC and AD, we need to identify which one is the adiabatic process, which one is the isothermal process. To differentiate these two processes, we will need to know about the gradients of the curve. To compare the gradients of these two curves, then of course we need to choose a point which is the intersection point at the two curves. So in this diagram, A is a point because A is lies on the AC and A is also a point on the AD. So if we look at this point and we draw a tangential line for the point A on the AD and also a tangential point for the point tangential line for the point A at the AC, then obviously we can see that this tangential line is steeper than this tangential line. So that means the gradient for the curve AD is steeper than the gradients of the curve AC. Therefore, this curve AD is for adiabatic and the curve AC is for isothermal process. Part B. To rank the heat absorbed in the three processes, we need to use the first law of thermodynamics to do the analysis. We look at the work done first. Work done is represented by the area under graph in the PV diagram. So from state A to state B, this is the area under graph for the process of isobaric. From A to C, which is isothermal, this is the area under graph. And from A to D, this is area under graph for adiabatic process. Therefore, the work done from A to B is the largest, followed by the work done for from A to C, and the smallest is the work done from the A to D. To analyze about the internal energy change of the three processes, we need to know about the temperature of the state B, C, and D. To know the temperature of B, C, and D, we use the isotherms that pass through these three states. We sketch the isotherms that pass through the state B. This is the one. And since the AC itself is the isothermal process, so this curve is the isotherm that pass through the A and the C. And for the D, this is a curve of isotherms that we sketch. And the states that lies on the isotherms that located at the right, the temperature is higher. So this one is the highest, TB is the highest, and TD is the smallest. Okay, so the C, which is the same as A, the temperature, is smaller than the TB and larger than TD. So we have this TB larger than TC larger than TD. Because the TB is larger than TC and TC is larger than TD, and the initial states for these three processes are the same, and the temperature of this initial state A is a TA, which is the same. Therefore, we can know that the change of the temperature for the process AB must be largest, followed by the temperature change for the process AC, and followed by the temperature change for the process of the AD. We know that the internal energy is a state function. It depends on the temperature T. Therefore, the internal energy change of the gas also depends on the change of the temperature. Since this temperature change for the process AB is the largest, therefore the internal energy change for the process of AB must be also largest, followed by the internal energy change for the process AC, and the smallest one is the internal energy change for the process AD. Follow the same sequence as the change of the temperature. Take note that state A and state C, they are on the same isotherms. Therefore, the temperature A and the temperature C are the same. So delta TAC is equal to 0, and thus the internal energy change in the process from A to C also equal to 0. And since there's a temperature drop from the A to D, this is a negative value. For delta TAD is a negative value. Therefore, the internal energy change for the process of AD also is a negative value. Means that the internal energy for the D is smaller than the internal energy of the state A. Now, based on the result of our analysis for the sequence of this work done and the internal energy change, we can easily conclude that since the Q is a summation of these two quantities, the Q for the process AB also must be the largest, because WAB and internal energy change for the process AB is the largest. Therefore, the QAB must be largest. And for the QAD must be smallest, because WAD and the internal energy change for the AD is the smallest. So in conclusions, this is the result that we have. The Q, heat absorbed in the process AB, is the largest, followed by the QAC and followed by the QAD.